section 1 of the exam, and it's quite a high mark for radar plotting. Now, why do we do radar plotting? Well, I'm going to point you towards MGN 379. Section 3, collisions have been frequently caused by failure to make proper use of radar and radar plotting aids in both restricted visibility and in clear weather. Common errors have been decided to alter course on the basis of insufficient information and maintaining too high a speed, particularly when a close course situation is developing. Information provided by radar and radar plotting aids in clear weather conditions can assist the watchkeeper in maintaining a proper lookout in areas of high traffic density. It's important to remember that navigation and restricted visibility can be more demanding, and great care is needed even with all the information available from the radar and radar plotting aids. Effectively, you and I are learning how to do radar plotting so that we can understand what our ARPA unit is doing on board. Do we need radar? Well, where would you find information on radar? What do you need on board a super yacht? LY3. So let's have a quick look at LY3. So page 101, LY3. A vessel should be fitted with the following additional equipment: echo sounder, GPS, speed and distance measuring, gyro compass, rudder angle indicator, and a 9 gigahertz radar. So 9 gigahertz, is that X or S band? X band radar. So yes, our boat will have radar. Does it have to have ARPA? Well, if we look at MGN 379, electronic radar plotting aids. EPA is a electronic plotting aid, and it means it can plot at least 10 targets, but without automatic tracking. Or we have ATA, automatic tracking aid, which is for vessels over 500 gross tons, and then ARPA for vessels over 10,000 gross tons. So we don't necessarily need ARPA, but we are going to have some form of electronic plotting aid. So for us to understand exactly what it's doing, we have to be able to do it manually. What do we actually get from the radar? Now you have to excuse my my rather good radar screen. So draw around it. There's us. We'll say we're going that way. That's our heading line marker. What we have is it will give us a range and a bearing. How do we get a range and a bearing? Well, you get the bearing using an EBL, and then you get a range using a variable range marker. So EBL, electronic bearing line, and that will give us a range and bearing. So at 12 o'clock, this target here was 040 degrees, that will say 5 nautical miles. That little symbol there means miles. That's the radar plotting, and normally in the question they will give you a range and a bearing, and they'll normally give you 3. We must have 3 because if you had the first one, second one, you assume it's going to do that, and then it does that. That shows you why you must always do 3. Yeah. So why do we do the radar plotting? We're trying to find out if there's a risk of collision. Yeah. So we do 1, 2, 3, and we'd have to do another 3, and that will give us, if we extend it, the relative motion line, CPA and TCPA. Okay. CPA, closest point of approach, TCPA, time to closest point of approach, and we can also work out the true course and speed of the other vessel and its aspect. To make our calculations easy, we do we work in plotting interval of 6 minutes. So it'll either be 6 minutes or 12 minutes. The reason that makes it easier is because it's 1/10 of an hour. We'll explain that as we go through. We must have 3 plots for accuracy. If we had, we'll say it's here, 1, 2, 3, you take the best out of the 3, okay? So you kind of average it out like that, yeah? That makes sense? You take the best of the 3. So let's have a quick lesson on radar plotting. Inside the notes, as you can see there, I put it on the screen, I've got each of these sequences down. So if you do find this confusing in the video, I'll make that available to you from within the app. So we're going to do an example. Now I'm going to switch over to pencil. And we're going to talk about what you need to be able to do this job correctly. The first thing you need is a pencil. It needs to be a nice sharp pencil. And it should be a 2B pencil, the same as chart work. You're trying to get accurate, but a nice, solid, confident drawing on your radar plotting sheet in the exam. You're going to need a set of dividers. Now these dividers, I suggest they're either the 8-inch or 11-inch. You need to be reasonably tight because that makes a big difference. If they're loose, then you put them down, you pick them up, it is just annoying. They need to be reasonably tight. I'm sure somebody will have a Leatherman. You then need a compass. Okay, it doesn't need to be quite as high tech as that one. Just a standard compass out of Sainsbury's would be perfect, or out of Staples. And then you need a set of parallel rules. Once again, if you look on my website, I've given you links to where I buy all my equipment from. Some of it's from Amazon, some of it's from a place in Bangor. They just seem very good. The Book Harbour across in Southampton is good as well. It needs to be fairly solid. It needs to kind of not be floppy. I know it sounds silly. You may have to modify yours. It just means that you can move it around gently and easily. Good tools seem to help. Let's do an example together. The first one we're going to do is own ship steering due north at 14 knots. First thing to do is write down your ship's heading here, or wherever it is on your plotting sheet, your speed, so 14 knots in this case, and the plotting interval, in this case 6 minutes. Don't worry if your plotting sheet's not the same as mine. It doesn't need to be. They're going to be round and they're going to have much the same concept. First thing I always suggest to do. Now, every teacher is going to be different. There is no right way, there is no wrong way. But there are ways that seem to reduce the amount of errors that you make. Now that is what I'm trying to do for you here, is I am useless at this. When I did this as an OOW, I found it very difficult. Actually, when I did it as a teacher, I still find it quite hard. So I definitely understand why it is that people lose marks. So I found, for me, and for the students I've taught, if you have a sequence that you do each time, you tend to reduce the amount of errors you make. So I always do the same thing each time, and it definitely helps. The first thing I'm going to do is mark on my heading. So a nice bold line, due north, put an arrow on the top there, and I decide which scale I'm going to use. So the first target at 12 o'clock is 5.5 miles away. So I'm going to score out the 12-mile scale. So on the plotting sheet there are 2 scales. One is for when you are navigating at 12-mile range and the other at 6-mile range. So we're going to use the 6-mile range. Okay, so the first target is 5.5 miles away. So you measure off 5.5, yeah, and arc it off like that. We're then going to use our parallel rules, and we're going to find the edge of that, 0.45 degrees. Yeah, and that is labelled O for original or orgasmic, because that's how excited you are about doing this. I like orgasmic. But O is for original. You put the time next to it, that's 12 o'clock. And then we're going to put the next plot in, so that's 4.5 miles. Measure it out. Now, I've watched a lot of people do this, and you know, there's nothing stopping you measuring out 4.5 miles and then gauging it like that. But let's be realistic. This exam is expensive. Yeah, sort of, if you took out the third week, you're looking at about £1,500 to £2,000, depending, I suppose, on the euro to pound and where you're doing it in the world. But a compass is a couple of quid. Go and buy a compass. Make your work neat. Because if you're anything like me, trying to be neat is not the easiest of things in the world, is it? The more I can do to help myself be neater and appear like I know what I'm doing to the examiner, the better I'm going to be. So that's the second plot there. I'm going to put a time next to it. It was 12:03. Third plot is 3.5 nautical miles, so measuring that off. So 0.45. These are all on a straight line because the bearing is remaining constant. There is going to be a risk collision. That is A. A stands for actual. That is where it actually is right now. Time for that was 12:06. So OA extended gives you the relative motion line. This gives you CPA, closest point of approach, and TCPA, time to closest point of approach. This will be labelled with one arrow and a circle around it to indicate it's the relative motion line. Okay, so we're going to label this target A and target ID A, CPA 0. We'll come on to it a second if it wasn't CPA 0, how you would work it out. That's always annoying. The first example anyone ever does with this is always CPA 0. It's just a little bit confusing, but that's the way it is. 0, that little squiggle there, that means miles. TCPA, time to closest point of approach. Now there's two ways of doing this. There may even be 3, there may even be 4. I guess there's many ways of doing the same thing. You can do it mathematically, or you can just step it off. I personally do it both ways, because it's a good cross-check to make sure I'm not losing marks. It's very easy to make a silly mistake. So the first thing I do is I measure the CPA point to where the boat actually is right now. So that's that distance there. 3.5 nautical miles. And I write that down on my working sheet. Don't forget, you're going to be working on your plotting sheet, and then you're going to transfer all of that working onto an A4 piece of paper in the exam. So distance equals 3.5 nautical miles. The relative speed, the relative closing speed, is your speed and his speed, which the resultant is this OA line. So this distance from O to A, yeah, that is how far or how quickly your resultant, your relative motion is between you and the other vessel. So that represents the time taken to travel that distance between the two of you relative to each other. So that is the closing speed, yeah, the relative speed in 6 minutes. So we take that across to here, and it appears to be, measure it properly, 2 miles. So 6 minute rule. If 6 minutes it's traveled 2 miles, he must be travelling at 20 knots. Speed 20 knots. Now I know that because I've been doing it for a while. If you were travelling at 12 knots, you would travel at 1.2 miles every 6 minutes. Let's just prove that, because I never found this bit easy. Yeah, I remember the teacher saying, you know, oh, it's obvious, he's travelled 2 miles in 6 minutes, therefore he's travelling at 20 knots. And I sitting there going, I'm glad it's obvious to you, but it's not obvious to me. I am numerically dyslexic, and I don't find this the easiest. But I do like it now. And I actually liked it on the day of the exam when I did it for real. So let's just prove that that is correct. Distance equals speed time. Now, it depends on how you were taught, where you were taught, the way, the year, the era that you were taught. But if you want to know the time or the speed or the distance, put your thumb over that, and it's distance divided by speed will give you time. Distance is speed times time. We're going to work out the speed, because we know he's done 2 in 6 minutes. So speed is distance divided by time. So speed equals distance, 2 miles, divided by 6. Speed equals, let's use a calculator, 2 divided by 6. That's going to give a random number. Times it by 60 equals 19.99999. So that's 20 knots. Therefore, that is proven. Okay? We do this on the app. In the 10 questions I do, I go through this about 10 times to make sure that you're happy with it. It's something that I can appreciate you may not understand fully at the beginning at this point, but when you've done it, we'll say, I don't know, 10 times for the app, and then 10 times in your class, you should be feeling quite confident with it. So distance is 3.5. We're going to say the speed is 20 knots. Yeah. So time, now distance equals speed time. Time is distance divided by speed. So in this case, it's 3.5 divided by 20. 3.5 divided by 20. 0.175 times by 60 put into minutes. Time is 10.5 minutes. Yeah, and that's 10.5 minutes after where we are actually at this moment. So we are actually at 12:06 plus 10.5 minutes. Yeah. So TCP, and this is important in your answer because people can make mistakes, or I can make mistakes with adding up. So I always write down TCPA is 10.5 minutes at, so 12:06, don't muck about, plus 6 minutes, 16.5. 12, 16.5. Yeah, happy? Now, we need to work out his true heading and his true speed. To do that, we need to take out our true course and speed from this equation. It leaves, the residual will be his true course and speed. Now, to do that, the easiest way is to line your parallel rules up with your heading, and you go opposite the arrow. That's why I draw the arrow on. So you go from O, it's okay when you're going north, when you're going south, it'll make much more sense. So you go back from O, and you just draw a line on. Okay? So that represents your heading. What represents your speed in this plotting interval? Well, we're travelling at 14 knots. So in 6 minutes, you will travel 1.4 nautical miles. Yeah. 14 knots, move it by 10, it's 1.4. So, distance equals speed time. if you want to work it out, just if you don't believe me. I'm going to mark off from O 1.4 nautical miles. So this point here is W. W-O, way of O. Okay? And you put an arrow on that to represent that. Then W-A is way of another, the true course and speed. And I always draw just a little boat there, just so I know exactly what's going on, because I find life difficult. Yeah, take that down. And I've got 271. It should have been 270. At this point, I'm not worrying, because plotting isn't necessarily about being 100% accurate. It's about getting the principle right. I would say if there's 10 people watching this and you all plotted it perfectly, you may or may not have got exactly the same mark. If you're within a degree, 2 degrees of what I'm getting, I'm happy, especially at the beginning. On the day of the exam, it would be good if you could be accurate. It really depends on your pencil width, doesn't it? It also depends on the quality of your printer, where your radar plotting sheets came from. You would hope that the ones at wherever you're doing this are better or proper quality. To check, just measure out, we'll say 5 miles. And then measure at that side. You see, mine doesn't line up. If you look at that, I'm out by about 0.1. I don't know why that is, but it seems to be fairly common. Some of them are better, some of them are worse. The examiners are very aware of it. So 271 is what I got there. 271 degrees. And that is the true course and speed of the other vessel. You label that with 2 arrows. W-A, way of another. 2 arrows. Happy? Good. His speed. So you measure W-A, way of another. Oops. And I have 14 knots. Okay, so his true course and speed is 271 degrees, 14 knots. As I said, you might have 270 if you're more accurate than I am at plotting. Accuracy has never been my strongest point. Understanding is good. Accuracy is difficult, isn't it? Next then we need to know aspect. Now aspect is a complex one. We need to know the aspect of the other vessel so that if we can apply the rules, if we could see him, if we can tell if he's a crossing situation, if it's an overtaking situation, everything in the rules is based on the lights that you would see, his aspect. So aspect is his bridge, what we would see of his lights. So in this case here, what we're trying to do, if we sort of extend WA, is we are trying to measure that angle there. That is the aspect. We would see, it's about 45 degrees, isn't it? So we put him there. Would you see the red light or the green light? I would see, looking at that, that's left, that's port. I would see his red light, so it's red. And we can either do one of two things. You can either use a protractor. This is a square protractor, it's a Douglas protractor, but the one that comes with your compass out of the £1 Sainsbury's or Marks and Spencer's or wherever you buy your equipment from. That angle there, that measurement from where we are in the center of the screen, because it's a relative one, to him is, we would see 45 degrees of his red light. Yeah. If he was, different position, you would see different aspects. So we can either use a protractor and put it on top, but we actually have a protractor here right in front of us, don't we? If we were to take this boat and we were to position that here, we've already got his heading. If we took his bridge through our bridge and extend it, we are effectively just moving him to the center of the thing and using these beautifully placed numbers to measure his aspect. We'll do that a couple of times together. But I find that to be the easiest way. So all you do is look at his bridge through our bridge. Yeah? And you put a nice manly line. So I've got two big solid lines there, and it's the big number less the little number. So 271 in my case, less 225 gives me 46. So it's red 46 degrees. Now it should be, in my trials before, and the fact that it's 045, it should be 270 and red 45. So I'm 1 degree out. Somewhere in there is a small error. I'm not too worried about a 1 degree error because I'd rather make sure I got the right concept at this point. As we go through the worked examples together, we will slowly get better and better, and I would expect by the time you've done all 10 of my quiz questions that we will be getting the same answer. Either you'll get better or I'll get better. Everybody happy of how we do that? That's it. Done. Let's do a few together. Let's do one more together. So it's up on the screen there. Own ship is steering 010 at 24 knots in clear visibility when the following target was detected. So ship's heading 010 degrees true. I'd like you to be doing this as well, so do download it. Press print. You can do it on A4. A3 would be better, but A4 will work perfectly well. And we will work together at the same speed. So you get your piece of paper, press pause, go through all the steps, and we'll see if we do it. I'll try and do it nice and slowly, and hopefully we'll be at the same speed. So 010 degrees true, speed 24 knots, and it's 1500 to 1506, so it's 6 minutes. Okay, so first target was 9.6 miles away, so we're going to be using the 12-mile scale. So I delete, remove that one so I don't make a mistake, and we're steering 010. Nice, solid, good line, nice and confident, good. 010 and 9.6. So get out your compass, measure 9.6, so it's 2, 4, 6, 8. 9.6, and it's bearing 064, so it's about over here. There's the first one here. So bearing 064, so use your edge. You're trying to be as accurate as possible, yeah? It's always easier said than done, isn't it? 064, yep, perfect. And we're going to label that one, what letter again? Orgasmic, O. So O, and the time of that plot was 1500 tea time. Second plot was 7.6 miles. Two, 4, 6. Yep, perfect. And 063, so it's about there somewhere. Yeah. So bearing 063 through the center. Six, 4, 6, 3, good. And that plot time was 1503. Just make it nice and clear. Good. And then 5.4, so I'm measuring 5.4. 5.4060, so it's about there. So 060. And that was what letter again? A for actual, wasn't it? A for actual. Time of that plot was 1506. So OA extended gives you CPA and TCPA, the relative motion line. So if we extend O through A, that'll give us the relative motion line. So we're going to label that one 1. Good. It's always important that you label it. You have like a method to your madness. It means that somebody else can take over or understand what it is that you're actually doing. So CPA. Now I said I'd come back to this. What you do is on your parallel rulers, assume you bought the right one, link is on my website, you go, that's it there. So you line up that with that relative motion line, and that is 90 degrees to that relative track. That is CPA, closest point of approach, not bow crossing point, but CPA, it's the 90 degrees to that line. CPA. I'm then going to measure it. So measuring angle here, measuring stick, measuring device, pair of dividers. I got it as 1 nautical mile. That little squiggle there that comes up in the camera is a nautical mile. Okay? Target ID, we'll make that one A. Time to CPA. So we're going to measure that distance there. And I have that as 5.2. Just rub out this one. Distance equals, what did I say, 5.2. And relative closing speed is from there to there. 4.2 in 6 minutes. That means 42 knots. Yeah. Sorry, it's travel. Let me just do that again. Let me do it slowly. You measure O through A, and that is 4.2 nautical miles in 6 minutes. So that's 42 knots relative closing speed. Time is distance divided by speed, so 5.2 divided by 42 times by 60, 7.42 minutes. So just under 7.5 minutes. Time equals 7.5 minutes. Yeah, happy? We can cross compare that 7.5 minutes. So if we look at that, that is 1 time interval, isn't it? So that's 1 1/4, 1 1/4, 1.25 times 6, 7.5 minutes. Yeah, I'm happy with that. I quite like the fact that you can do it mathematically and then just step it off. It was only ever designed to be stepped off. It was never designed for this to take forever. This is meant to be a quick, work out who's going to hit you, when they're going to hit you, and which boats you have to worry about. That's the kind of the point of all of this. Yeah, it's 1 1/4 time intervals. That's it. Happening quite quickly. So TCPA, 7.5 minutes. What time was actually? It's 15:06. So 6 plus 7.5, 13.5 minutes. So it's at 13.5. Happy? Heading, as I say, if you're out by a little bit, or your numbers don't match mine, I have done all these at least 3 or 4 times. They're not always the same number, they're always within 1 or 2 degrees. As long as I'm within 1 or 2 degrees, I'm actually quite happy. We're going to do RWO, way of owns. We need to find where W is, so it's directly back from that arrow, from O, so opposite the arrow. And it is 24 knots. So 24, move the decimal place, is 2.4. So I measure off 2.4. There it is there, beautiful. So that is W, O, way of own, R, course and speed, W, A, way of another, the true course and speed of the other vessel. Yeah, and that has 2 arrows. And as I said, I always draw a little boat, a little triangle in the end there. It just helps me visualize what's going on. So bring that back. So as I said, try and be as accurate as you can. So I use the lines. There's lines on these parallel rules, and they are very helpful for making sure you're getting a very accurate score. It's a bit of practice, but you get there in the end, normally. So I'm reading that as 285, 286, 287. Heading 287 degrees. That's his true course and speed, or true course. For his speed, we've got to measure WA. So I'm reading that as 3.6. So he's traveled 3.6 in 6 minutes. He is doing 36 knots. Aspect. Now he said aspect is his bridge through our bridge. So we're measuring from, it's quite a good one to explain. I'm just going to do it with like a dotted line. Yeah, I'm just going to be measuring that angle there, because that's the light we can see. Is it going to be a red light? I always put that on top, and I know that's the left side, lefts and rights, port and starboard. Some of us are not the cleverest. We've just learnt to produce strategies that allow us to reduce the amount of errors. So for me, I have learnt methods for reducing my errors, methods for learning. I actually spent a long time at university studying learning and how we do it, and different ways of understanding and different ways of putting it together. So as a teacher, I enjoy it because I struggled. I had to find ways of doing things that would allow me to score a high mark. By high, I mean just pass. That's why the oral preps and my nav and radar GSK, you know, I do understand when you say something that you don't understand it, because it doesn't come naturally to me. Taking something apart and putting it back together again, that does. Practical stuff I like. This stuff, you know, I'll be sweating. It's hard. It could be the lights, but it isn't easy, and I appreciate that. So to find the aspect, we're looking to measure that angle from there to there, what we can see of him. So to do that, we've already got one manly line there, which is his heading. If we take that through the center there and put another manly line there, it's as if we've moved that to there. So we're using that angle there is actually the same angle as that. Yeah. So to work out the aspect, it's going to be red. So write down red. And then it's 287, so a big number, 287 less 239, 48. Red, 48 degrees. Now hopefully you've got the same score, or the same, not score, the same answers as I do. If you don't, and you're a few degrees out, Don't stress, don't redo it, don't panic. Yeah. It's just an understanding at this point. I hope this has helped you to understand how you find the CPA, closest point of approach, TCPA, time to closest point of approach, the other vessel's true course and speed, WA, way of another, and then his aspect. If the question could always go on and say, well, what would you do if this was reduced visibility, restricted visibility? It would be section 3 of part B, the steering and sailing rules, and it would be under rule 19. I would avoid an alteration of course to port for a vessel forward of the beam, other than for a vessel being overtaken. We're not overtaking here, therefore I would avoid going to port. I would either turn to starboard or I could slow down. I would say at 24 knots we'd probably slow down, but just he's going so quickly. If it was clear visibility and we could see the other vessel, that's an important aspect, we can see the other vessel visually out of the window, it would be section 2 of the rules, in which case it would be rule 15, and we would alter course to starboard. A broad alteration of course to starboard, sound 1 short blast of the ship's whistle of about 1 second's duration. In your exam for nav and radar, they ask what are you going to do if it's restricted visibility, say under rule 19, I would avoid an alteration of course to port for a vessel forward of the beam other than for a vessel overtaking, therefore I'd go to starboard or slow down. If it was good visibility and you could see the other vessel, it's rule 15, and I would make an alteration of course to starboard. And don't have to go hours and hours into this, I just want to know that you know the rules. Good, moving on. What's next on the agenda? As I said, all of these are worked out for you inside the notes, so you can cross-check the notes against what I'm saying. It does help a little bit when you can highlight it and go back. They are available for download, and then you can press print. The answers are there. Several of the questions in the exam go on to say what happens if the vessel slows down or you speed up, or what happens? What's the new CPA? What's the new time to this new CPA? I'm sure you've seen the questions. So let's just move on and do one like that. Our ship alters course. This is a hard one to explain with words. So it's actually easier to show it to you in a video. So we'll do a full question. We'll have our ship steering 350 degrees true at 20 knots, clear visibility. We sight this other vessel. It's a 6-minute plot. He's on a constant bearing, so risk collision does exist. And then part B is a couple of minutes later, we will alter course to a new heading with the immediate effect. Okay, so we'll just start, we'll run through it together right from the beginning to the very end. First thing to do, ship's heading 350 degrees true, ship speed 20 knots. And just sharpen the pencil again. The sharper your pencil, the more accurate you'll be. Plotting interval is 6 minutes. It's the 12-minute ones that are difficult, aren't they? I've got plenty of examples of 12-minute ones inside the other bits, the app. So 350. That's terrible, Fred. Half a degree out. Unbelievable. Three, 5, 0. As I said, trying to be accurate is not an easy thing, is it? So, what scale are we using? We're using the 6-mile scale, so we can get rid of the 12-mile scale. Otherwise, I will use the wrong one, I'm sure. First target, 5.2. So, let's go 5.2. And that's 035. 4.2. And and 3.3. Once again, try and be accurate. The first one there, second one, third one, and we can actually already extend that through. We know that's going to happen there. So we've got O for A. O stood for original, and that was at 10 o'clock, 10:03, and 10:06. Don't forget to label it. It's a very easy way of losing marks. So CPA is 0. Make this target ID A. 0. Yeah, because it's a constant bearing. Time to CPA. We actually already know that distance, don't we? Let's rub out my bit over here. We already know that distance because they've given it to us. That is 3.3. So distance is 3.3. You can measure it, but it should be the same, assuming I've been accurate. And speed, or relative closing speed, let's just measure that. So 1.5, 1.8 is what it should be. We can work it out mathematically because they've given us that as well, I guess. 5.2 less 3.3, 1.9. Ooh. Yeah, fair enough. You can see how important it is to your thickness of your pencil, can't you? I've got a 3B pencil here. Not giving myself an excuse, but it is quite soft, but it is quite nice that you can see it. So that's 1.9. 1.9 miles in 6 minutes. So what speed is he traveling at? 19 knots. Move the decimal place. So we've got 3.3 divided by 119 times by 60 to give me the minutes. 10.42 minutes. So 10 minutes. 10.42. 10 minutes. 10.5 minutes would be the more accurate. But 10 minutes, 11 minutes. They only need it to the nearest minute. Just confirm that we're happy with that. So just step it off. So that's 1. So that'd be 6 minutes. Yeah, so just under 12 minutes. About 10 minutes. Yeah, happy with that. TCPA is 10 minutes at 10:06 plus 10, 10:16. I'm impressed enough to use a calculator there. If you need to use the calculator, use the calculator, yeah? You're allowed it in the exam, so you'd be silly not to use it. Next, we're going to work out his course and speed, his true course and speed. So we line up our heading, we go opposite the arrow, comes back from O. Good. We're traveling at 20 knots, so in 6 minutes we would travel 2 miles. So measure off 2 miles. By the way, if you didn't score off the top one now, you'd have made a mistake there. So I hope you scored off the top. Yeah, measure the right scale. 2 miles. Just have to extend that one slightly. 350. So that's W there. W-O, 1 arrow. W-A, way of another. Take that down. So, 2 arrows, and as I said, I always draw a little boat on the end, or a little arrow. That's my artistic skills. And I read that as 287. So heading 287 degrees. Speed WA, way of another, his true course and speed, so measure that. And he is doing 1.5 in 6 minutes, so he is doing 15 knots. Aspect, it's his bridge through my bridge. CPA is 0, so that makes it slightly easy. 0.35. So, big number less the little number. 287. 287 less 215 equals 72. Would it be the red one or the green one? Going that way, that's his port hand side, so it's red and 72. Good. Part B of this question then. At 9 minutes past 10, own course is altered to 0, 2, 4. Okay, so 6 minutes to 10, 9 minutes, 7, 8, 9. So 3 minutes later. 3 minutes later. So I'm not sure. I always measure that distance there and divide it by 2 and then just check it. Yeah, so we know that's 19, so that's 1.9. 1.9 divided by 2, 0.95. Let's check that, looks like it's halfway. Yeah, 0.95. Here we go. Let's check that again. Beautiful. Yeah. So that point there is 10:09, isn't it? Because what they're saying is at 10 o'clock he was there, 10:03 he was there, 10:06 he was there. At 10:09 we did something. So between 10:06 and 10:09 was our thinking time. So nothing happened till that moment. Now, can we change his course and speed? Is there any way we can telepathically say, yeah, no, I can't make him change his course and speed. The only thing I can change is our course and speed. What represents our course and speed? W, O, way of O. So I can't alter W, I can't alter A. The only thing I can alter is O. So that is what we're going to alter to represent this change of course. So 024. So 024, so we find out what 024 is. Yeah, and you take it to W. Now before we were going that way, we are now going to steer 024, which is that way. Yeah, one arrow there. So before we were steering 350 and we've altered course to 024. That's what represents it. Now have we changed our speed? In this example, no we haven't. So our speed inside the plotting interval remains the same. So that was WO before. Yeah. That is now WO1, way of O. That represents our course change from 350 to 024. That means that the new relative motion line is O1A. Yeah? But we haven't done it at 10:06. We did it 3 minutes later. So we extend that down, we walk that down to there. And that is our new relative motion line if we alter course to 024 at 9 minutes past 10. So the new CPA comes off that and that is CPA. So we measure that, so let's just write down new CPA, measure that. And does that make sense? We were going that way, we've altered that. He is going to pass further ahead, isn't he? Makes perfect sense. So I think that's quite important that you do that in your exam and in your workings. Is what I'm being told, what I would expect to happen in real life. So that is 0.8. So new CPA equals 0.8 nautical miles. Time to CPA, I'm going to measure that distance there. And that is 2 miles. Write that down now working. So distance equals 2 nautical miles. Relative closing speed. Now this is a hard one. This is where people get mistakes. That OA was our relative motion line. The new relative motion line when we alter course is going to be O1A. So that represents the new relative motion in this plotting interval. Yeah, it's going to be just under 6 minutes. Let's just measure it, do it mathematically. 2.6, so 26 knots. Time is distance divided by speed, so 2 divided by 26, times by 60 to bring it to minutes, 4.61, 5 minutes. Which matches what I would expect, doesn't it? That represents 6 minutes, it's about 5 minutes. 4.61, so 4.5 minutes if you're being very, very accurate. New TCPA. I mean, at this point, I just want to get the right minute. It's fine. New TCPA, 5 minutes. Now, when is this 5 minutes from? It's from the 10:09. 10:09 plus 5 minutes, 10:14 will be the new CPA. Okay, happy? Now, as I said, your answer, my answer could be slightly different. I'm not worried about degrees and minutes too much at this point. I am as we get closer to the worked examples as we work through together, but as long as you understand, that is the priority. That's the end of the YouTube section. For more information and for 10 worked examples with every scenario, with every format, so I've got course changes, I've got speed changes, I've got you changing course to do this, I've got rules of the road that come in with it. Do download the app. It's available on the iPhone, it's available on the iPad, on an Android device. I'm sorry. Android users, I'm sorry. Android users, I'm sorry. I'm not there yet. It could be in the future, it might be something I'll look at. Best of luck to you all. I hope it's helped some of you, and good luck.